So welcome to part 2 of the video for determining the rate law of a reaction based on experimental data. So we have this reaction here balanced with hydrogen and chlorine gas combining to give you HCl. And there's a table that gives you the time, the concentrations of hydrogen and chlorine gas, and then the rate of the reaction. And from this table, we can determine what the rate order will be. There's two ways to do this. So method 1. I can look at this table and see, okay, when does the concentration of hydrogen not change, but the concentration of chlorine does change? And that is going to be the interval right here. Concentration of hydrogen remains constant at 1, while the concentration of chlorine gas drops from 1 to 0.75. So the concentration of chlorine dropped by 1/4, or by 25%. So what happened to the rate when that concentration of chlorine dropped? Well, the rate went from 0.05 to 0.0375. So it changed and dropped by 1/4. So the change in the concentration of chlorine is negative 1/4, right? And the change in rate was negative 1/4. So because the change of the concentration of chlorine was the same as the change in the rate in terms of what percentage it changed or what proportion it changed by, that means this is a first order reactant. So chlorine is first order. So if I'm doing the rate law up here now, we've got rate is equal to K times the concentration of H2. We're not sure yet what that is, so we'll just say to the M, and then the concentration of Cl2 to the first. Now H2, between time interval 1 and 3, the concentration of hydrogen drops by 1/2, from 1 to 0.5, whereas chlorine stays constant at 1. Right, the cells in the table don't need to be next to each other for you to use them. Right, chlorine's constant between 1 and 3, hydrogen drops by half between 1 and 3. If we go over rate, the rate is constant between 1 and 3. So when hydrogen changes by 1/2, the rate doesn't change at all. That makes hydrogen, so the change in hydrogen is equal to minus 1/2. The change in rate is 0. That makes hydrogen 0 order. So we can write the final rate law down here. Rate is equal to K times the concentration of H2 to the 0th times the concentration of Cl2 to the first. We don't even have to write hydrogen. We can take that out. And the rate can just be K times the concentration of chlorine to the first. So that means the overall reaction order is 0 plus 1 to give an overall reaction order of 1. So K in units is inverse second. Now there is a second method, so method 2. Sometimes how much a concentration or a rate changes is not easily identifiable. It may change by like 0.38, which you can't tell, 0.38. So what you can do is you can use a ratio, and this will always work. So I'm just going to plug in the same numbers for this ratio, and we'll get the same thing. So for this ratio, you say rate 2 over rate 1 is equal to K times the change in concentration. Let's do chlorine first. 2 over K times the change in chlorine concentration 1, or what is the chlorine concentration at each of those, all of that to the N. And that N is the order of chlorine. So the K we can cancel out because that's constant. So if I'm plugging in rate 2, that's 0.75 over rate 1. Oh, sorry, I'm plugging the concentrations here. Okay, so let's plug in the rate, right? Rate 2 is 0.05, and rate 1 will be 0.0375. It doesn't matter which one we do as long as we keep it consistent. I could have done 0.0375 on top and 0.05 on the bottom, but I just have to keep it constant. So that means since I did 0.05 first for the rate, I do 1 on top and then 0.75 on the bottom. So when I do this math, I'm going to get, plug this into my calculator, 0.05 divided by 0.0375 will give 1.33. And then 1 divided by 0.75 is 1.33. To the N, right? This is all to the N here. So that means N is equal to 1. If I were to do this for H2, let me move to a new page so we have room. So rate 2 over rate 1, right? The rates are constant. So it's 0.5 over 0.5 is equal to 1.0 over 0.5 to the N. So that means I have 1 is equal to 2 to the N. Right, I want to make sure I got the correct numbers there. So anything to the 0th power is 1, so that means N is equal to 0. So those are the two methods for using a table of experimental data to then determine the rate of the reaction and the rate order of the reaction.